So this is for Pre-Calc 11, Chapter 6, Section 4. What we're going to do is we're going to solve for rational equations. And that's just, again, fancy way of writing or saying fractions. We're solving for fractions, okay, with a variable. So here we have a 4 and an x as a denominator. We know that the common denominator would be 4x. And so what would I do? I would multiply this term by x, this term by 4, and then this final term by 4x, and then we would all have the exact same common denominator, right? So that leaves me with an x squared plus 24 all over 4x, right, is equal to what looks like 14x all over 4x. Now, if you sort of imagine, we all have the same common denominator. If we wanted to, what we could do is we could multiply now, again, everything by 4x. And what that would do is that would eliminate all of these terms 4x, and then what we're left with is just an expression of x squared plus 24 is equal to 14x. Now this should look familiar. It's a quadratic equation, so what we can do is we go x squared minus 14x plus 24 is equal to 0. And in our previous lessons we were able to factor this. So let's see what two numbers multiply to 24 and add to negative 14. I think it's 2 and 12, right? So we can draw our little x trick. Negative 14, 24. What two numbers add to negative 14 and multiply negative 4? It's negative 2 and negative 12. So we have x negative 2, x negative 12 is equal to 0. And right now it looks like our possible solutions for x are x is equal to 2 or 12. Now, always look back at the original equation. What's the non-permissible values? Well, if you take a look, the non-permissible values, x cannot be allowed to equal 0. So these solutions are fine. Next equation. It says here 9 over x minus 3 subtract 4 over x minus 6 is equal to 18 x squared minus 9x over plus 1. So I think the common denominator here would be, I'm just going to assume that it's going to be x squared, x minus 3, x minus 6. That means I need to multiply the numerator by x minus 6, so that's going to be 9 bracket x minus 6. Subtract, right, there's that subtraction symbol. And then 4 over x minus 6, I'm going to multiply it by x minus 3, so it's going to be 4 over x minus 3. And again, I apologize for my handwriting. This works out to 18 over x squared minus 9x plus 1. What two numbers add to negative 9 and multiply to 1? Ooh, I don't know. That looks pretty hard. Oh, that actually is a typo. That's a typo, everybody. That should be 18. Okay, I'm just going to pause for a second. Okay, yeah, so it's a typo. It should be x squared minus 9x plus 18, which actually conveniently is the exact same denominator we have in the on the left-hand side of the equal sign. Now, again, what we could do is we can multiply everybody by x minus 3, x minus 6, and then everything goes away. So now we have an expression that looks like this. It's 9x minus 54, negative 4x plus 12, right? There's a negative 4, and then we distribute the negative 4 to these two terms, is equal to 18. So we're going to combine like terms. That gives us 5x minus, I believe it's 44, is equal to 18. Did I say 44? I meant 42. Okay, so I'm going to bring the 18 over, or sorry, I'm going to bring the negative 42 over, so this becomes 5x is equal to 60, and x is equal to 60 divided by 5, and I think that's 12. Now let's double check our non-permissible values. Well, our non-permissible values are x's can't be 3 or 6. So that seems okay. Alright, so we're going to move on. Let's see, this one here. It says here 3x over x plus 2 minus 5 over x minus 3, x squared minus x minus 6. Oh, those are the same factors. So I'm going to multiply top and bottom by x minus 3. So it's going to be x plus 2, x minus 3 in the denominator. I need an x minus 3 here, so I'm going to multiply that by x minus 3, so it's 3x, x minus 3. And then this is going to be negative 5 times, well, this has an x minus 3, needs an x plus 2, is equal to negative 25 over x plus 2, x minus 3. And again, we're going to use the same strategy. We can multiply everything now by x plus 2, x minus 3, and I don't know why I'm missing brackets here. So that cancels that out, and that out, and that out, right? Numerator, denominator, cancel it. And then I'm left with what looks like 3x squared minus 9x, right? I distribute that. And then this is a minus, so it's minus 5x minus 10 is equal to negative 25. And let's see, what does this work out to? If we simplify everything, this becomes 3x squared minus 14x. What looks like plus 15 is equal to 0. Now, I would ask you, do you remember how to see if we can factor this? There was a strategy that we used. If this was not a 1, we would multiply these two numbers, right? And then we would draw our little x trick. So negative 14 is our middle term, negative 45, 45. What two numbers add to negative 14 and multiply to negative 45? Hopefully you know that it's negative 9 and, oops, did I say negative 9? It's going to be, oh, so I made a little mistake here. This actually should be negative 25 becomes positive 25, so it's going to be positive 15. So this becomes positive 45. Right, so what two numbers multiply to positive 45 and add to negative 14? 3 and 15? No. Let's see. So I'm going to go through all the combinations of multiplying to 45. So it's going to be 1 and 45. That's not useful. 3 and 15. That's not useful. 5 and 9. Oh, there you go. 5 and 9. So let's see. Negative 9, negative 5. Perfect. And we use those two terms and we split up the middle term. So it becomes 3x squared negative 9x negative 5x plus 15. And then we just group. And we ask ourselves, what's the greatest common factor? That's going to be a 3x, x minus 3. What's the greatest common factor for the second pair? That's negative 5, x minus 3. Oh, what's the greatest common factor again? It's x minus 3, 3x minus 5. And all of this, of course, is always equal to 0. Oh, what are the possible solutions? Oh, x is equal to 3, right? And 3x minus 5, we set that equal to 0. X is equal to 5 over 3. Now, the only thing we have to do next is to make sure that the non-permissible values, the original question said the non-permissible values, x plus 2, well, x can't be equal to negative 2. X minus 3, x can't be equal to positive 3. So let's double check. Oh, so of course here we have a possible solution that equals 3. This is what's called an extraneous root. Because if we allowed it to equal x equal 3, the situation would have a denominator of 0. So extraneous. Okay, it's extraneous. E-O-U-S. This is an S. I apologize. Okay. Moving on to some word problems. So it says here, Stella takes 4 hours to paint her room. It takes Jose 3 hours to paint her room. How long will it take they work together? Well, let's write some of the information down. It takes Stella 4 hours. It takes Jose 3 hours. That's if they're working on their own. So fraction of work done in 1 hour. Well, if it takes 4 hours, Stella can do it every hour, 1/4 of a room. Jose takes 3 hours, so every hour he finishes 1/3 of a room. Together, we don't know how much time it takes together. So what fraction is it? Well, as you can sort of see, it's a reciprocal. Okay? So fraction of work done in X hours. Well, Stella can do it in 1/4 times the amount of time it takes. Jose can do it in 1/3 times the amount of time it takes. Well, how much time or how much of a job can they finish? Well, 1 over X times X, which is equal to 1. So how do we do this now? We use these terms. So this becomes 1 over 4X is Stella's contribution plus 1 over 3X, which is Jose's contribution, plus, is equal to 1 whole job complete. All right? So now, let me just write it as X over 4 plus X over 3 is equal to 1 over 1. All right, what's the common denominator? Well, it's 12. So I'm going to multiply everybody by 12. And this is going to show you something kind of interesting. 12x over 4 plus 12x over 3 is equal to 12 over 1. We can simplify this. This becomes 3x plus 4x is equal to the number 12. 7x is equal to 12. X is equal to, this is the amount of time, right? 12 over 7 hours. Okay? And we don't have any problems with the denominators. There's no non-permissible values. Okay? Alright, moving on to the last problem. It says here, a train is scheduled to run 160 kilometers between two cities on Vancouver Island. The average speed is decreased by 16 kilometers an hour. The run will take half an hour longer. What's the average speed of the train? What's the equation of the triangle? Well, way back in science class, they made you draw a triangle, and it says distance traveled is equal to the rate in which it travels times time. So if you hide any one of these, so let's say you're looking for distance, you put your hand over distance, it's v times t. If you're looking for time, you hide time, it becomes d over v. And the same thing, if you're looking for rate or velocity or speed, you hide speed with your hand, it becomes distance over time. Okay? Alright, so the distance. Well, we know the distance is 160 kilometers traveled, right? Well, we don't know what the average speed is, but if we're looking for time, we hide time, we know that the expression becomes distance divided by time. So it's 160 over x. Now, what happens when the train is slowed down? Well, does the distance change? No. Same distance. But we know that it says the average speed is decreased by 16 kilometers an hour. Well, here's the average speed right here, right? Because it's slowing down, it's going to be whatever the average speed is minus 16 kilometers. Well, how much time is that going to take? Well, time, again, we hide time. It'll be distance divided by r. Well, the distance doesn't change, but the rate does. There you go. Okay? Now, we know that when it says here the average speed is decreased, if the average speed is decreased by 16 kilometers an hour, it takes half an hour longer. So if the average speed is decreased by 16 kilometers an hour, the run will take half an hour longer. Okay, well, why don't we do this? We know that the train travels at 160 over its average rate. We know that. But if we slow it down, whatever time this is, we're going to add half an hour to it. It's going to equal the slower rate, right? And the slower rate is this one, right? This is the faster rate. So if we were to add half an hour to it, it would equal the slower rate. All right, so now we have a denominator of x, a 2, and an x minus 16. It's just a matter of finding the common denominator again. Hopefully you would agree it would be 2 times x minus 16 is equal to 2 times x minus 16. And let me put brackets around that. All right, so I'm going to multiply 160 by 2 times x minus 16. So it's going to be 2 times x minus 16 times 160 plus, well, I already have a 2 here, so I'm going to multiply this by x and a minus 16. And then it's going to equal 160 times a 2 times an x. And we can get rid of everything in the denominator just by multiplying by 2 times x minus 16. And that cancels every one of these guys out. Okay? I'm not going to waste your time distributing it all out. I'm going to tell you exactly what it works out to. It works out to 320x minus 5120 plus x squared minus 16x is all equal to 320x. Now, right, the denominators are now gone, and so if we simplify this, this becomes x squared minus 16x minus 5120, and all of this is equal to 0. We can factor this actually. I'm not going to waste your time. I'm going to just show you that it's factorable. It's x minus 80, x plus 64 is equal to 0. Oops, that's an equal 0. Alright, what are my solutions? Oh, x is equal to 80 or negative 64. Hey, can you have a negative 64 speed? Does that make sense to you? So, we're going to eliminate that. That becomes an extraneous root. So what is the average speed? X is equal to 80 kilometers per hour. Okay, I apologize this video is a little long. You might have to watch it again. I just want to let you know that I avoided multiplying or distributing all this out. You can do that on your own, okay?